Okay, class, what we're going to talk about today is, again, chapter 8 is about polygons and area. And today we're going to focus on angles in polygons, whether we be talking about interior angle sum theorem, or exterior angle sum theorem. Okay. Objective 1 is recalling what it means for a polygon to be equilateral, equiangular, and regular. We talked about in yesterday's lesson. We won't cover that again, but if you want to do some extra practice concerning objective 1, you can always flip back at the end of the video um, to recollect what happened there in objective 1. Objective 2 is understand the definition of interior and exterior angles of a polygon. Third, we're going to use the polygon interior angle sum theorem. Fourth, we're going to use the interior angle sum theorem for regular polygons. Noticing that in objective 3, we're not talking about regular polygons. And then in objective 4, we're going to use the interior angle sum theorem for regular polygons. And lastly, fifth objective, understand and use the polygon exterior angle sum theorem. Okay, again, if you want to come back to the objective 1, which is review at a later time, you can. Okay, first, before we get into this idea of interior angle sum theorem and exterior angle sum theorem, we need to understand what does it mean for an angle to be interior as opposed to exterior. Okay, if you're looking at the two diagrams, the one on the left, inside of this triangle, you'll notice that inside, maybe you want to call those three angles orange, or maybe you want to call them red, but what we're highlighting there is the three interior angles. In I like to say it's more orangish to me. Those are called the three interior angles. Okay, and if you can see faintly the exterior angles of the triangle, okay, those are actually, I think they're in the color blue. Those are actually considered the three exterior angles of the triangle. So I'll try and highlight them here. There's one exterior angle of the triangle. Here's another exterior angle of the triangle. And there's the third exterior angle of the triangle. Now the three interior angles would be there, there, and there. So we need to just understand the difference between interior angles as opposed to exterior angles. Okay. Okay, third objective, use the polygon interior angle sum theorem. Okay, first and foremost, let's count how many sides this convex polygon has. It has 7. Therefore, we know it's a convex heptagon. Okay, so first and foremost, I'm going to label the vertices A, B, C, D, E, F, Z. See, I got you. I know what you were thinking. I went with Z there. Okay. It says starting from the same vertex each time. It doesn't matter which vertex you pick, by the way. How many triangles can you make inside the heptagon below? So first, let's do that. Pick a vertex. It doesn't matter which vertex you choose. But let's start at point E. Well, if I went from point E to point D, I couldn't make a triangle. So I won't go from point E to point D. Okay? Because that won't allow me to make a triangle. If I go from point E to point F, that didn't create a triangle either. Okay? So starting at vertex E, going to vertex C makes a triangle. I'm going to say that's triangle number 1. Starting back at point E again, or that vertex E, all the way to vertex B, that created a second triangle. Starting back at vertex E, going all the way to vertex A, created this triangle. And then from E to Z. So I want you to notice that we have 5 triangles there. Okay, it's a convex heptagon. A heptagon has 7 sides, and I want you to notice that there's 5 triangles inside. Okay, next question says this: what is the sum of the interior angles? Well, we first got to recollect what is the sum of the interior angles of a triangle. Well, the sum of the 3 interior angles of a triangle is 180 degrees. And if there's 5 triangles in a convex heptagon, then the sum of the interior angles is going to be found by n minus 2 times 180. N represents the number of sides. So if this is a convex heptagon, we're going to go 7 minus 2 times 180 degrees. 7 minus 2 is 5. And then 5 times 180 will give us the sum of the interior angles of a convex heptagon. I did that right. 5 times 180 degrees would be 900 degrees. So the sum of the interior angles of a convex heptagon is 900 degrees. So the expression we're going to use today to find the sum of the interior angles of a convex polygon is going to be n minus 2 times 180, where n represents the number of sides. Why minus 2? If you missed it earlier, because when I was starting from point E, I could not make a triangle from point E to point D. And when I went from E to F, it didn't create a triangle. And that's always going to happen no matter which convex polygon we're dealing with. We're not going to be able to make triangles in two directions, if you will. That's where the minus 2 part comes in at. Okay, let's do some examples again. Some more examples. Example 1, find the sum of the measures of the interior angles of the convex polygon. Let's look at letter A. Well, how many sides does it have? 1, 2, 3, 4, 6 sides. Okay, so we can take the traditional route. Start at any vertex. Doesn't matter which one. Start creating triangles. Again, notice I cannot create a triangle from here to here or from here to here. Let's count how many triangles we have in here. Well, there's 4 triangles in there. So we got a convex hexagon, okay, which means it has 6 sides, and there's 4 triangles in there. Okay, so the long route is the way I just showed you, by finding how many triangles are inside of this convex hexagon, by actually drawing the triangles and then realizing that there's 4 triangles in there, and that the sum of the 3 interior angles of one triangle is 180 degrees, but we have 4 triangles, so the sum of the interior angles in this convex hexagon is 4 times 180 degrees, which is going to be 720 degrees. Now, at some point, we're hoping, and we'll do this with letter B, that you can stop drawing these triangles and start to realize that how many ever sides this convex polygon has, the number of triangles will always be 2 less. Why? Because if you look back at letter A, we can't, if you look at the 2 green segments, when I went those 2 directions, it didn't create a triangle. That's where the minus 2 part comes in. Okay, so let's take a look at letter B. Okay, let's count how many sides this convex polygon has. 1, 2, 3, 4, 5, 6, 7, 8. So this is a convex, help me out, octagon. It's a convex octagon. So it has 8 sides. Okay, and if it's got 8 sides, using this expression, n minus 2 times 180 degrees, it's got 8 sides. N represents the number of sides of the convex polygon. Okay, 8 minus 2 is 6. So we got 6 times 180 degrees, and 6 times 180 degrees I believe is 1080 degrees, if I calculated that correct. Yes. Okay, so the sum of the interior angles in this convex octagon is 1080 degrees. If you still feel like you have to see how many triangles fit in there and then just multiply that number by 180 degrees, do it. I showed you using n minus 2 times 180 degrees. Okay, example 2, it says find the sum of the measures of the interior angles of the convex polygon with n sides. Notice we don't have a diagram here, so in letter A, understanding. Okay, what we're doing, n minus 2 is how many sides it has, minus 2, because you can't make 2 triangles in 2 directions. That's where the minus 2 comes in at. So if it has 10 sides, it's definitely a pentagon. I apologize. I don't know why that was there, why I put that there. Okay, if it has 10 sides, it's a decagon, which means it has 8 triangles inside of the decagon. So now we're talking about 8 times 180. Well, 4 times 180 would be, so I think 8 times 180 would be 1,440 degrees if I calculated that correctly, using mental math. Okay, for letter B, if it's a 15gon, okay, again, using how many sides it has, minus 2, times 180 degrees. So a 15gon definitely has 13 triangles inside of it. So we're talking about 13 times 180 degrees, which is some large number. I can't do that mental math, so we're going to work this out here. Okay, 3 times 0 is 0. 3 times 8 is 24. Carry the 2. 3 times 1 is 3 plus 2 is 5. Okay, 1 times 0 is 0. 8 times 1 is 8. 1 times 1, 1. Adding down vertically, 0. 4 plus 0 is 4. 8 plus 5 is 13. Carry the 1, 2. So the sum of the interior angles in a 15gon is 2,340 degrees. Okay, if you want to do part C on your own, you can. We're going to move on here. Okay, let's apply this now in a little different sense. We're still going to find here, we still want to know what the sum of the interior angles of the convex polygon are by figuring out how many triangles are inside, which is n minus 2 180. But then we're going to use that and set up an equation to find the missing angle measurement. So in part A, notice that it is a convex quadrilateral. So it has 4 sides. And if it has 4 sides, it definitely has 2 triangles in it. So to find the measurement of angle A, we're going to take measurement of angle A plus the measurement of angle D, which is 101 degrees, plus the measurement of angle C, which is 68 degrees, plus the measurement of angle B, which is 92 degrees, which is equal to n minus 2 times 180 degrees. Remembering the n minus 2 times 180 degrees is going to give us the sum of the interior angles in this convex quadrilateral. So we have measurement of angle A. We're going to combine our like terms on the left side of the equation. So we're going to go 101 plus 92, which would be 193. So 193 plus 68, I believe is 261, equals, it has 4 sides, so it's 4 minus 2 times 180 on the right side of the equation. Okay, now we need to simplify the right side of the equation. So 4 minus 2 is 2. So there's 2 triangles inside of a convex quadrilateral. That's what the right side of the equation interprets to, 2 times 180. So we have the measurement of angle A plus 261 equals 2 times 180, which is 360. Then we subtract off 261 from both sides, and we're left with the measurement of angle A, which is going to be equal to 99 degrees. So the measurement of angle A is 99 degrees. Okay, let's take a look at letter B. Actually, we won't do all of these. Let's do letter D. Okay, so in letter D, let's count how many sides this convex polygon has. 5 sides, so it's actually a convex pentagon. Okay, so again, if you need to go back to the original method starting at any vertex, you would notice that if it's a convex pentagon, there's 3 triangles inside. Okay, why 5 sides, 3 triangles? It's always 2 less. Why? Because if I started from vertex D, I couldn't make triangles from there and there. The blue segments didn't create triangles. That's where this whole minus 2 part comes in at. Okay, so if you still need to figure out how many triangles are inside visually, go ahead and do that. Okay, so here we go. To find the measurement of angle A in letter D, we got the measurement of angle A plus the measurement of angle D plus the measurement of angle C plus the measurement of angle B. Well, those segments are perpendicular, which means that's a 90-degree angle is what that box means there, is equal to n minus 2 times 180. Of course, I've already shown to you and explained that there's three triangles in there, but I'm going to work it out. So on the right side of the equation, It's a convex pentagon, so it has 5 sides, minus 2 times 180 degrees. On the left side of the equation, combining some like terms, we have the measurement of angle A plus, now we're going to combine 80 with 130 plus 90, so I think that's 300 degrees there. Okay, so we get the measurement of angle A plus 300 degrees is equal to 5 minus 2, which is 3, times 180 degrees. As we work through this problem, we have the measurement of angle A plus 300 degrees is equal to 3 times 180, which will give us the 540 degrees. Subtract 300 from both sides of the equation, and we get the measurement of angle A is equal to 240 degrees. So the measurement of angle A is 240 degrees. Okay. Now, listen, objective 4 is using the interior angle sum theorem for regular polygons. So basically, if we go back here to this page and you understand what we're just doing, and we'll just focus on D here, okay? These convex polygons were not regular, okay? What we were doing to find the sum of the interior angles on this page were taking the number of sides minus 2 times 180 degrees. And then we were combining like terms and subtracting to find the missing angle measurement. We're still now going to use how many triangles are inside of this convex polygon. We're just adding the fact that it's now regular. So if we go to this page, you first need to remember what it means to be regular. Well, being regular means that all the sides are congruent, so it's equilateral, and all the interior angles are also congruent, so it's also equiangular. Okay? So this is a regular octagon. So this is a regular octagon. So if it's a regular octagon, it means it has 8 sides. I already know it has 6 triangles in there, applying what we just learned on a previous page of n minus 2 times 180. So the sum of the interior angles here is going to be found by the number of sides minus 2 times 180. So applying that in this regular octagon, 8 minus 2 times 180 degrees. There's 6 triangles definitely in this regular octagon. So 6 times 180 degrees is 1,080 degrees. Okay? Now, the difference is this. Because this polygon is regular, okay? Because it's regular, okay, now means that each of the interior angles have to be the same measurement. Okay, which now means I can take the sum of the interior angles and divide by the number of sides it has, and that will give me the measurement of each interior angle here, which would be 135 degrees. So the measurement of each interior angle here inside of this regular octagon is 135 degrees because it's regular. So I'm taking the sum of the interior angles and dividing by the number of sides. We didn't do that here. Okay, there was no dividing because these weren't regular polygons. Okay. Okay. Let's do this at least one more time. In example 1, it says name each regular polygon and then find the measure of an interior angle. Okay, so letter A, this is a regular hexagon. And a regular hexagon has 6 sides. So we're going to find the sum of the interior angles by figuring out how many triangles are inside. But if you missed what we just did, we're going to then divide that by the number of sides because it's a regular hexagon and each interior angle has to be the same. Okay, so it's a regular hexagon, so it's 6 minus 2 times 180 degrees divided by how many sides it has. It's a regular hexagon, 6 sides. So there's 4 triangles inside of this regular hexagon, but then we're going to divide that by 6 because each interior angle has to be congruent. So doing some simplifying, 4 times 180 would be 720 degrees, but dividing that by 6, we're going to get 120 degrees. So each interior angle of a regular hexagon is 120 degrees. Remember, we're taking the sum of the interior angles, which is 720 degrees here, dividing it by 6 because it's a regular hexagon. Okay? If you would like to come back to do more of those, you can. Okay, last but not least, fifth objective, understanding and using the polygon exterior angle sum theorem. Okay, let's first remember what an exterior angle is here. So if we focus here on this convex pentagon, if you look at angle 1 in blue, okay, that's one of the 5 exterior angles. Then we got a second exterior angle there. There's a third exterior angle here. And there's a fourth exterior angle here. And then you have a fifth exterior angle in there. The bottom line is this: when you take those 5 exterior angles that I put in blue, red, green, purple, and orange, and you put them together, they make a circle. And that will always happen, no matter how many sides the convex polygon has, if you take its exterior angles and put them together, as shown on the right, they will make a circle. And you need to know that one rotation of a circle in degrees is 360 degrees. So let's apply that. Here's what we just talked about. That in this convex quadrilateral, there's one of the exterior angles. There's the second exterior angle. Here's the third exterior angle. And here's the fourth exterior angle. And if I took that green angle, the blue angle, the black angle, and the red angle and put them together, they would make a perfectly united circle, if you will. And one rotation of a circle is 360 degrees. So we know that the sum of the exterior angles of any convex polygon will be 360 degrees. So applying that notion here, we're going to take one of the exterior angles plus the other exterior angle plus the other exterior angle plus the other exterior angle, always equal to a nicely made circle, 360 degrees. Combining like terms on the left side of the equation, we get 3x plus 180 degrees equals 360 degrees. Subtracting 180 from both sides of the equation, we get 3x equals 180, dividing by 3, arriving at x equals 60. So we now know this angle right here is 60 degrees because that's the value of x, and this angle right here is 2 times 60, so the angle measurement here is actually going to be 120 degrees. And you're going to notice that if we asked you to, 120 plus 60 plus 95 plus 85 would definitely equal 360 degrees. I believe we have concluded with this lesson. Thanks for joining in.